In this session, we will continue to look at solutions to past paper questions from CSEC Additional Mathematics. We'll be looking at question 6 from 2022. So paper 2, 2022, section 6, well, question 6 rather, from section 4, which deals with probability and statistics. All right, so let's begin by looking at this question. Now, one of the keys to successfully doing any question is to read the question carefully, right? A lot of times we, and I'm saying we because I'm including myself, we tend to just not read carefully and then we miss out important information or we don't answer the question that we're required to answer. So we have to read the question properly. All right, so this question says, at a school canteen, 80% of the students, S, purchase chips, C, and 25% purchase chicken, K. Of the students who purchase chicken, 11% do not purchase chips. All right, let me read it again. At a school canteen, 80% of the students, S, so S represents the entire student population, as is evidenced by being outside the rectangle, which of course is representing the Venn diagram and of course the entire universal set, right? So S, 80% of the students S purchase chips, C, and 55% purchase chicken, K. Of the students who purchase chicken, 11% do not purchase chips. So this number, this 11%, of course, is important. So here we have our circles which are representing the two sets. C represents essentially the percentage of students who purchase chips, while K represents the percentage of students who purchase chicken. And of course, the region of overlap will be the intersection of those sets that represents students who buy both chicken and chips, which of course is a good combination, right? Now, let's focus on the 11%. We're told that 11% of those students who buy chicken do not purchase chips. And therefore, that 11% belong to the region of chicken only. We can call it that. So for those students who buy chicken only, or no chips, then that is 11%. And in terms of the Venn diagram, that goes right here. So 11%. Good? Now, the percentage of children or students who buy chicken is 55. And it therefore means that if 11% do not purchase chips, then of course we have 55 minus 11 equals 44% that purchase both chicken and chips. And so that 44 goes in the middle here to represent the percentage of students who buy both chicken and chips. So of course, those two numbers add to give 55. Now, at the school canteen, we're told 80% of the students buy purchase chips. So since we already have 44 here, then what number must go inside here to make up that 80%? What do? We simply subtract 44 from 80. So we say that 80 minus 44, and that gives us 36, yeah, 74 plus 6, 36%. And so that number goes here, 36%. And that number basically represents the percentage of children at the school who buy chips only. Now, when we add up these numbers in these circles, what do we get? Let's see that. We have 36 plus 44 plus 11. Now we know 36 plus 44, that gives us 80. 80 plus 11 equals 91. So basically, 91% of the students at the school buy either chicken or chips. So what becomes of the other 9%? The other 9% must lie without these, outside these circles. And so we must therefore put 9 anywhere outside these circles. And having done that, we now represent the entire cohort of students at this particular school. All right? So that is how we approach that particular question. Now, let's move on to look at what else the question requires of us. So, part 2, it says, Determine the probability that a student chosen at random purchases only chicken or only chips, right? So this says, determine the probability that a student chosen at random purchases only chicken or only chips. Now, these two events are what we call mutually exclusive. What exactly does that mean? It means that they cannot occur simultaneously. So what does this mean? If a child purchases only chicken, obviously they can't purchase only chips. So it's either or. And so these are said to be mutually exclusive. And so if we can say that, I would say, how do we express this? So we can say that the probability that a child purchases, I will put chicken only. So this is, sorry, C is for chips rather. So probability of a child purchasing chips only or chicken only. So from the data, this of course the probability of purchasing chips only plus the probability of purchasing chicken only. And we're adding them because they are mutually exclusive. If you purchase chicken only, you cannot also purchase, what did I just say? Chicken or chips? I'm confused. If you purchase chips only, then you cannot purchase chicken only, and so on. So it's one or the other. And so we see basically say that these are mutually exclusive events. And because we want to find the probability of a child or a student purchasing only chicken or only chips, we will add the respective probabilities. Now, what we have in the Venn diagram are percentages, but of course, percentages can be represented in terms of probabilities as well, right? So basically, the probability of chicken only, sorry, C is for chips. I must remember C is for chips. The probability of chips only or chicken only would be equal to, from the diagram, is going to be the region where it's chips only plus the region where it's chicken only. And so this gives us, in terms of percentages, let's just first express it in terms of percentages. Where's my cursor? I can't see. So this would be equal to 36%, right? Because that represents the percentage of students who purchase chips only, plus the 11% who purchase only chicken. And that gives us 47%, or in terms of a decimal, 0.47. So basically, this means that 47% of the students at the school purchase either chicken or chips only, and that means the probability of a student purchasing only chicken or only chips is 0.47. All right, so 1 mark for that. But having constructed the Venn diagram accurately, then doing this part, of course, would not be very tedious because we'll be able to get that information from the Venn diagram. All right. So let's now proceed to the other part of the question. Let's remove these. All right, part B says, oh, that part is finished. So that was all pertaining to part A of the question. Let's move on to part B. Now, part B says the probabilities of the the probabilities of the occurrence of two events A and B are given by P of A equals a quarter, P of B equals 3/5, and P of A union B is equal to 7/10. Determine P of A and B, or we say P of A intersect B. Now, this of course is quite similar to the union of sets. When you're looking at sets, you'd use a formula, for instance, that the number of elements in A union B is equal to the number of elements in A plus the number of elements in B, and you subtract the number of elements in A and B, right? So that is how we normally apply the formula for the union of two sets, where of course the two sets overlap. In terms of probability, the formula basically remains the same, except that instead of n, we use p. So we can say that p of A or B is equal to P of A plus P of B minus P of A and B. And why do we subtract P of A and B? When you add these two, you essentially add the intersecting elements twice. And so you must subtract it once. Okay? That is exactly why. So using this formula now, we can basically say that we're given P of A union B. So we have 7 over 10 is equal to P of A, which is a quarter, plus P of B, which is 3 over 5. And this is minus P of A union B. Let's just call it X for a while, right? Let's just call it X. So let's go ahead and simplify our fractions on the right-hand side. So we have 7 over 10 equals, now we can write these fractions as having the same denominator, which would be 20. And so this, of course, is 5 over 20 plus 12 over 20 minus x. And since we have the common denominator being 20 on the right-hand side, we'll just do something similar to the left-hand side as well. And so basically, we'll write this as 14 over 20 is equal to 17 over 20 minus x. And this clearly tells us that x is equal to 17 over 20 minus 14 over 20. And therefore, x is equal to 3 over 20. And this therefore means that the probability of A and B is equal to 3 over 20, right? So that is how we calculate the probability of A and B, or A intersect B, given that we have P of A, P of B, and P of A union B, or P of A or B, right? So that is the answer there. So we can basically put it right here that P of A and B is equal to 3 over 20, which of course is the same thing as 0. What's this now? 0.15, right? I think 0.15. Yes, 0.15. Good. Now let's look at part 2. Now part 2 has P of A, and that looks like a vertical slash B. Now how do we interpret this? P of A slash B. Now this is read the probability of A occurring. So OCCU are how many R's in occurring? 2 R's in occurring. The probability of A occurring given B has already occurred, right? This is what this signifies. So this signifies the probability of A occurring given that B has already occurred. And this, of course, is what we refer to as a conditional probability. So this is read P of A given B, which of course is interpreted as the probability of A occurring given that B has already occurred. And there's a formula for working this out. Let me just clear my screen. So how do we calculate this probability? Now, the formula is this. P of A given B is equal to P of A and B divided by P of B, right? So the probability of A occurring given that B has already occurred is the probability of both A and B occurring divided by the probability of B occurring. So it's almost as if the probability of B occurring essentially becomes the sample space, right? And so this gives us, we scroll up to look at our values. Well, P of A and B, which we just calculated to 3 over 20. So this gives us 3 over 20, and we're going to be dividing by P of B, which is 3 over 5. So we have 3 over 20 divided by 3 over 5, which of course is the same thing as 3 over 20 divided by 12 over 20. Same thing as 3 over 20 times 20 over 12, which gives us 3 over 12, with the same thing as a quarter, or 0.25. And so the probability of A occurring, given that B has already occurred, is a quarter, or 0.25. All right? Good. Now let's look at part C of the question. Part C says, state with a reason whether events A and B are independent. Now what exactly are independent events? Independent events are events where the occurrence of one does not affect the occurrence of the other. Let me repeat that. If two events are independent, the occurrence of one is not affected or does not affect the occurrence of the other. Let me give an example of independent event. Suppose you're tossing a coin. Let's say you're tossing a coin 2 times, and it's a fair coin, right? On the first attempt, you obtain a head upon tossing the coin, and you want to ask now the probability of getting a tail on the second attempt, given that the first was a head. Now, these events are independent. When you toss a coin, the second coin, when you toss a coin the second time, whether you obtain a head or a tail has no impact or is not impacted by what you actually obtain on the first toss. And therefore, these are independent events. And how do we show it mathematically? If two events are independent, we say that the probability of A and B is equal to the probability of A times the probability of B. And if this statement is true, then it means that events A and B are independent. Now let's check this. What is the probability of A intersect B? We found that in part 1 of the question, that is 0.15, which is 3 over 20. So let's substitute it here. So say that 3 over 20 would be equal to, now what's P of A? P of A is a quarter, and P of B is equal to 3/5. So we have 3 over 20 equals 1 over 4 times 3 over 5. And let's multiply this out. 1 times 3 equals 3, and 4 times 5 is 20. So this statement is actually true. And because this statement is true, it therefore means that A and B are independent. So A and B are independent, and the reason is that this statement is true. P of A and B equals P of A times P of B. As a matter of fact, this is generally how we show that two events are independent. The probability of them occurring together is the probability of one occurring independently times the probability of the other occurring independently. And as we saw from the calculated results, their probability of occurring together is not different from their probability or their combined probabilities of occurring what's the word opposite of together? By themselves, right? So P of A intersect B equals P of A times P of B. And if that statement is true, it means that the events indeed are independent. All right, let's proceed. All right, so here we have, what do we have here? We have a box which shows some results of a test, right? The following table shows the marks obtained by 27 students in a mathematics test. Construct a stem and leaf diagram to display this data, right? So they want us to construct a stem and leaf diagram to display the data. Now, the stem would be the major part of the score, and of course, the leaf would be the minor part. And let's identify the stem by looking at the scores, right? So looking at the scores, you see that we have scores in the 30s. So the first 3 scores are in the 30s. The next scores are in the 40s. Then, of course, we have 2 scores in the 50s. We have 1, 2, 3, 4 scores in the 60s. 1, 2, 3, 4, 5 scores in the 70s. Let me see. 1, 2, 3, 4, 5, 6 scores in the 80s. And of course, we have 1, 2, 3, 4 scores in the 90s. And these numbers, of course, will form the stem of this stem and leaf diagram. All right? So let's start our construction. Now, before we start the construction, let's count how many numbers will have a stem of, say, 3. How many numbers are in the 30s? We have 30, 35, 39. So we have 3 numbers in the 30s. In the 40s, we have 42, 45, 45. Another 3 numbers in the 40s. In the 50s, we have 52 and 59. So 2 numbers in the 50s. In the 60s, we have 61, 61 again, 65, 69. So we have 4 scores in the 60s. We have 70, 71, 75, 77, 79. That's 1, 2, 3, 4, 5. 5 scores in the 70s. In the 80s, 1, 2, 3, 4, 5, 6 scores in the 80s. And of course, 1, 2, 3, 4 scores in the 90s. And we're told The scores are for 27 students, so these numbers should add to give 27. Let's check. 3 plus 3, that is 6, plus 2, 8, plus 4, 12, plus 5, 17, plus 6, 23, plus 4, 27. Yes. So these scores actually add to give 27. So let's now proceed to make our stem and leaf diagram. So let me see, we have one, two, three, four, five, six, seven stems, right? So 7 stems. And we have at most 6 leaves, which correspond to the stem of 8. So 1, 2, 3, 4, 5. Oh, I'm not supposed. Is that supposed to? Yeah, something like this. Yeah. All right, yes, something like that. So let's proceed to filling out our stem and leaf diagram, right? Stem and leaf diagram. We actually do not need those extra rows. But anyways, these are the stems that we're going to put in first. So these would be 3, 4, no, 3, 4, 5, 6, 7, 8. Let me start at the top there. So 3, 4, 5, 6, 7, 8, 9. All right, so these are the stems. Now for the leaves, we see that we have 30. So the leaf, of course, is 0. We also have 35, so the leaf is 5. And we also have 39. So we have 3 leaves for that particular stem. For the stem 4, we have 2, 5, and 5. So we have 2 for 42, 5 for 45, and we also have 5 for 45 again. For the stem of 5, we have 2 leaves, so that would be 2, 9. For the stem of 6, we have leaves 1, 5, 9. Oh, 1, 1, there, we have 1 twice, so we have 1, 1, 5, 9. For the stem of 7, we have 1, 2, 3, 4, 5 leaves. So that is 0 for 70, a 5 for 75. No, a 1 first. A 1 for 71, then a 5 for 75, 7 for 77, and of course a 9 for 79. Right? For the stem of 8, how many of those do we have? We have 7, 8. We have actually 6. So we have 83, so a stem of 3. 83, sorry, no, start with 81. Missed that one on the top there. So 81 first. So 81, then we have 83, then we have 83, then we have 85, and then of course we have 87, and lastly we have 89. So 9 is out here, right? And then for stem of 9, we have 4 leaves. So we have 90, we have 90 again, so another 0. We have 95, and we have 98, right? And of course, you should always check that all our scores are represented. So we have 1, 2, 3, 4, sorry, 3, 3, plus 3, 6, plus 2, 8, plus 4, 12, plus 5, 17, plus 6, 23, plus 4, 20, 27, right? Now, for the most part, stem and leaf diagrams do not have vertical lines like this, but of course, because my handwriting is not the best, I use the lines to actually separate the stem, separate the leaves, rather, separate the leaves. So I could just basically take out some of them to represent what the stem and leaf diagram typically looks like, right? So yes, it usually looks something like that without the lines, but of course, we should make sure that our leaves are sufficiently spaced, all right? So typically it looks something like that. And if you have a diagram like that, we should be able to identify all the scores by simply putting the stems and the leaves together, all right? Good. So that was worth 4 minutes. So let's go to the next part of the question. The next part of the question says, state one advantage of using a stem and leaf diagram to display the data. Now, the question asks for one advantage, but we'll try to list as many of them as we possibly can. Now, if we go back and look at the data, what do we notice? How many scores we had in the data that was given to us? We had 27 scores. So we had a total of 27 scores in the data that was given to us. And how many scores are represented in the stem and leaf diagram? The same number, 27. So what does this tell us? It tells us that the stem and leaf diagram represents all the data values. So all the data values are represented by the stem and leaf diagram, and of course that is one advantage, right? So all the data values are represented, right? That's another advantage. Now, if we look at how the data are organized, we can see that they're written in order. So we have the stems, for instance, 30, which is, well, 30, 35, 39 in increasing order. Then we have the next stem in increasing order, 42, 45, 45, then 52, 59, 61, 61, 65, 69, and so on. And because these are arranged in order, it therefore makes it easy to find the median, right? So it's easy to find the median. So it's relatively easy to find the median. That's another advantage. Easy to find the median. And of course, if we find the median, that means we're able to locate the other quartiles. So I guess I could say it's easy to find the quartiles as well, right? Um, The stem and leaf diagram, because it basically represents all the scores, it also gives a very decent or very good idea of the overall distribution of the scores, right? So it gives a good representation of the distribution. And of course, it can be used to compare two distributions. So it gives a good overall picture of gives an overall picture of the distribution. And of course, it can be used to compare two distributions, right? So basically, those are some advantages of the stem and leaf diagram. Now, even though the question only asks us for one advantage, try to list as many of them as possible. Now, since they're advantages, there must be at least one disadvantage. And one disadvantage, of course, is that let's say we have a very large number of data points, number of data values, and we're required to complete a stem and leaf diagram. It would be rather tedious. It would be rather tedious, and as a result, one main disadvantage is that stem and leaf, stem and leaf diagram is not the most practical way of representing large amounts of data. All right, so that is one major disadvantage of the stem and leaf diagram. So now let's move on to the next part of the question. Says 3, state the range of values of the marks obtained by the students. Now, typically when we speak about the range of values, we're talking about the interval between the lowest mark and the highest mark. Now, clearly from the data set, the lowest mark is 30, and of course, the highest mark is 98. So we're talking about the lowest stem and the smallest leaf to the highest stem and the largest leaf. And this, of course, is say that the range of values is from 30 to 98. Sometimes they actually give us the range in terms of the difference between the two values. And so we can also state that the range would be given by 98 minus 30, which is equal to 68. All right, 1 mark. Now, the last part of the question, part 4. Part 4 of the question says, They give us a little diagram. What is it? We'll talk about that. The data are displayed in the following box and whisker plot, right? So the data are displayed in a box and whisker plot. And we're asked, state two distinct observations about the data as seen in the box and whisker plot. Now, first of all, when we plot a box and whisker plots, I mean, if you're required to plot one, of course, it must be drawn to scale, which means that in the exam you're required to use graph paper or at least use a ruler to draw it to scale, right? Now, should a box and whisker what exactly should a box and whisker plot show, right? The box and whisker plot should show the lowest score, the lowest the lowest score, and in contrast to that, it should also show the highest score. And both conditions are satisfied here, right? What else should it show? It should show the lower quartile, referred to as Q1. It should also show the upper quartile. So the upper quartile, referred to as Q3. And in between that, it should show the median, which we commonly refer to as Q2, or we could say the middle quartile, or what is called the 50th percentile. So these are the things that the box and whisker plot should show. It should show the lowest score and the highest score. It should show the lower quartile Q1, the upper quartile Q3, and the median, which is often referred to as the middle quartile or the 50th percentile, right? Now, the question says, state two distinct observations about the data as seen in the box and whisker plot. So there are quite a few. So we'll try to state as many as we possibly can. The lower quartile is 52. Now, what is the significance of the lower quartile? The lower quartile is also referred to as the 25th percentile. So 25th percentile. And what this basically implies is that 25% of, in this particular case, these are scores in a test by students. And this would imply that 25% of students scored below this value, right? So 25% of students scored below this value. Good. Now, what else does it show? It shows the upper quartile, which of course, Q3, which of course is equal to 85. And this is also referred to as the 75th percentile. I'm just going to put percent and ILE, right? 75th percentile, which of course implies that 75% of all students scored below this value, right? That is significance of the upper quartile. Also, of course, obviously, if we jump from the lower quartile to the upper quartile, it means it also shows the median Q2, which of course is also referred to as the 50th percentile. So the 50th percentile, right? And what this therefore means is that 50% of all students scored, well, below this value. So 50% scored below the value. And of course, being the median, it should also imply that 50% of students scored above that value. All right. What else? The range of data we can distinctly the range. The range, of course, is the span from the smallest to the largest score. So this, of course, would basically be 98 minus 30, which of course gives us 68, right? 68. Let me see. We identified the quartiles, the lower quartile, the middle quartile, and the upper quartile. And of course, if we have the lower quartile and the upper quartile, we can determine what is called the interquartile range. The interquartile range, I'll just abbreviate that, IQR is equal to the upper quartile Q3 minus the lower quartile Q1. And since we have these values, the upper quartile is 85 and the lower quartile is 52. So 85 minus 52 gives us 33. And what is the significance of this? This represents what is called the middle 50% of the class, right? So these basically represent the middle 50% of the scores. And of course, right? So that is the interquartile range, right? There's also some other things we can actually imply from the box and whisker plot. Now, if you notice, the median is not exactly midway the box, and nothing is wrong with that. The median score of 71 is actually closer to 85, which is the upper quartile, than it is to 52, which is the lower quartile. And we can just verify this by finding the difference between them. 71 minus 52, that gives us 19. 85 minus 71, that gives us 14. So what this basically shows is that the median is closer to the upper quartile than it is to the lower quartile. And the significance of this is that basically this suggests that there's a greater concentration of scores towards the higher mark or the higher end as opposed to towards the lower end. And this is the significance of that, right? Another thing we can also check for is the presence of outliers. Now, whenever we have a data set, there may be some values which are significantly smaller than most of the values, and there may be some other values which are significantly larger than the other and most of the values. And these are referred to as outliers. Now, how do we check for outliers? Now, again, the question did not require all of this, but I'm just going a little bit beyond what the question requires, right? Now, how do we check for outliers? First of all, we determine the interquartile range, which we already did. So the interquartile range is 33, and we determine 1.5 times the interquartile range, which of course is 1.5 times 33, which gives us 33 plus 16.5, that is equal to 49.5. Good? And then what do we do with that value? We find Q1 minus that. So Q1 minus 49.5, this would be equal to, now Q1 is a lower quartile, and this gives us 52 minus 49.5, which gives us, what's that, 2.5. And we also find Q3 plus that value. So Q3 plus 49.5, which of course gives us, what's this now? 85 plus 49.5, and that gives us 85 plus 15, that is 100, so 134.5. And we actually check if there are any scores within the data sets that lie beyond these values. In other words then, is there any score that is below 2.5, or is there any score that is above 134.5? And in both cases, the answer is no. And this is an indication that there are no outliers, right? So there are no outliers as evidenced by these values. And this is pretty much almost everything that we could actually observe from this box and whisker plot. So this is the end of this question. This was question, let's see, question 6, section 4 from 2022.